Buongiorno a tutti, benvenuti. Io sono Roberto Lovecchio, sono vice caporedattore di Quattro Ruote e oggi ho il piacere e l'onore di moderare questo convegno con ospiti davvero di eccezione. Parleremo di digitalizzazione, di intelligenza artificiale, una frontiera in
Artificial intelligence is an ongoing process. Given the limited time at our disposal, about 45 minutes, we would like to analyze the state of the art concerning two aspects, namely the economic fabric of the Motor Valley area from the point of view of businesses, the business community, and the point of view of consumers, users who use their cars that are either drivers, car drivers, or passengers, namely all of us. Connectivity today delivers so much data that is almost endless. That is not so easily manageable, whereas AI, artificial intelligence, provides us with the main best tool to unbundle, process data, to collect data, and to make it useful as a change accelerator, delivering companies a way to increase and enhance their competitiveness, but also a tool to better understand what to expect on the market.
I contorni e la direzione. Allora,
given the limited time at my disposal, not to waste any time away from our guests, let me give the floor to Christian Richter, who is the Google automotive person. And I've got two questions for him. Very synthetically, development of network and digitization during the pandemic, a very difficult and challenging time, but a time that has also served as a catalyst and accelerator of many dynamics. Secondly, Mr. Richter, we would like you to take stock of the situation of infotainment and connectivity tools within cars. And also have an idea of the future challenges that Google is now addressing. Richard, to you. Christian, to you the floor.
Slides here. I hope you can see the slides. Yeah, perfect. Well, thank you again for having me here. And what I'm going to talk about today is, there are three big topics in auto. The one is how the car is powered, electrification, then how the car is experienced, the connected car. And the thing I want to talk about today is how the car is purchased and what's happening to the channels and all the disruptions we've seen during COVID, and how AI actually can help deal with this.
I'm sorry, Christian, I can't see the slide. I don't know about.
Christian, I'm sorry if I'm interrupting you. Scusate.
Coming out of lockdowns, going back to normal, they actually are staying on that high level. So they're not going back. So the transformation to more digital sales that we've seen during Corona is actually substantial. This is here to stay. This is a new normal. And so let's talk about how we are going to deal with this. Also, what we're seeing, this is from a study which we do every month with thousands of car buyers around the world, is yes, people want to buy the car online, but they still want the dealer to be part of it. So for example, you see about 25% prefer home delivery, and still almost 50% prefer a pickup of the car at the dealer. So this is not about pure online retail, even so pure online retail is becoming more and more important. It's actually not about pure stationary retail. This is actually about making both work, which is known as omnichannel. What we also see is that omnichannel is a big thing. What you see here is a real car buyer journey. All the touch points the car buyer does with the website, the CRM system, the call center, the dealer, physical touch points, all of this over the car buying journey. So typically car buyer journey has about 900 touch points. So the question is, how do you, how do you make sense out of this data? How do you actually make this data work for you? And when it comes for making really a lot of data work smartly, we actually bring AI into the picture. So just a bit of terminology. AI is the science of making things smart, and machine learning is a technique developed to do AI. Also, I think one good way to make a differentiation between machine learning and traditional linear programming is traditional linear programming. You give an input and you give an algorithm and you get an output. So the algorithm is defined by a human, come up like the formula. Machine learning is different. What you do in machine learning is you give an input and you give an output, and then the machine gives you the algorithm. And this algorithm can be so complex and so non-linear that it basically would have never been able to be done by a human, because it basically mimics neural learning. By the way, that's also how children learn, right? I mean, they see an apple, they hear the word apple, and they make the connection in their head and build it. It's basically really mimicking human learning. So how do you bring this into innovation? How do you actually work if you have a big challenge, a big problem? And this is how at Google, how we deal with it. We call it the framework which we use in our edge steps. And three things that come together. The first thing is you deal with the problem. For example, one problem is how to make computers learn like a human. Then what you need is a breakthrough technology. And then you combine both into actually a radical solution. So for example, in this case, deep learning and also dealing with lots and lots of data. The solution was cloud computing. Tools which are actually used for graphic processing and work very, very well also for machine learning. And the radical solution was to basically combine both of this into a company that is working to, it's really focused on artificial intelligence, machine learning. It's known as DeepMind. And it has recently beaten the World Human Championship Go, which is the most complex game in the world, as I've learned myself. So, but what does this mean for auto? How can you, for example, make it work if you're selling cars? So this is the live picture of, for example, how AI can do a customer communication. And again, think about input and output. Input is the customer data, all the segment data, the behaviors, the age groups, and all of this. Output is whatever you want these to do commercially. You want them to buy, you want them to develop a high gross margin, you want them to upsell or sell on and all of this. And basically the machine then, based on the input and output, groups the data into segments with the highest propensity to actually do the desired thing you want the segment to do. And we do know that, for example, between the top and the bottom segment can have up to 80% higher propensity to buy or higher conversions if you do a segmentation. This is segmentation which a human would never do. We also use AI a lot at Google. We use it for virtual assistant, traffic predictions, online fraud detection, delivery services, unique recommendations, all of these things. It's always the same principle. At the end, we use AI wherever there are large data sets and complex problems. In manufacturing for predictive maintenance, financial services for risk analytics, and so on and so on. Big data, very, very complex problem. This is when AI comes in. In auto, specifically, there are four things you can do. The first thing is you can optimize ROI. This is when you go into advanced marketing analytics. So you actually do more with less data. You understand the customer journey, you can predict outcomes. Next step is if you integrate with you move to real channel. Then you can go deep in customer insight and as customer's messaging, you can automate the interaction through automated context. I mean, think about it. The brand type of Volkswagen has 15 models now, and there's almost no showroom in the world where you can actually show all the models with all the different variations and sizes. So it sometimes makes the entire experience. You can then sell more and smarter with better planning and forecasting, cross-selling, upselling, and you can even activate the wider ecosystem by monetizing the car generated data from charging interactions if it's an electric vehicle and other. So to finish it and to come back to the X framework, what's the big problem? The big problem is that very often the omnichannel is very, very tricky. The dealer doesn't talk to the CRM system, doesn't talk to the customer call center, doesn't talk to the OEM website. A lot of data is lost. The tech is there. There's AI and cloud, and you can use this to integrate the data along the entire customer journey. And it's actually funny. I work for a tech company. I can tell you, the tech is not the most important because the tech is there. You can buy it. You can buy from us, you can buy from other companies. There's really, really, really good tech outside that you can buy. The problem is more, and this is a radical solution, is how do you change your organization to make it a true omnichannel organization across OEMs, dealers, partners. So this is not a tech challenge. This is a leadership challenge. You need to start to break through the silos. You need to make sure that this entire thing, everything along the customer journey is working as one organization. And all the players have actually really, really embraced the organizational and leadership part first and foremost. And it puts the tech to work and the results are really, really good. Again, I'm from a tech company. I tell you, this is not a question of tech. This is a question of leadership, as you're all leaders in the room. I want to do this thought. Thank you very much. And back to the discussion. Thank you.
Scusate, avevo messo il microfono.
Sorry, my mic was muted because I didn't want to disturb the first speaker's presentation. I would like to thank Richard for his presentation. The sound was very poor, and even the slides could not be visible. Anyway, we tried and grasped some of the key messages in his presentation. And now Stefano Marzani, who is in the automotive sector, a principal specialist solutions architect, autonomous vehicles at AWS. Cloud is a way to manage data. Cloud provides us with a practical advantage, namely that we are not depending on a specific device. But please try and help us understand what the difference will be for consumers, the ones that, of course, use cars, and what is the change for companies. So deep learning, machine learning, as Mr. Christian Richter said. I've got a third question, actually. I mean, with the autonomous driving that makes time free for the previous driver, and we are talking about the autonomous driving solutions that are brought to the extreme, but even with the use of augmented reality with an interaction between external reality and the analysis made by the vehicle when approaching various types of environments. I mean, all this opens up new, interesting opportunities for Amazon and many other companies for the supply of services. Information about shops, restaurants, purchase of tickets for museums, and so on and so forth. Can you please tell us something about it? Yeah, what you said is absolutely true. First of all, I would like to thank you for the invitation. I'm very happy to meet virtually Mr. Bozzoli, Flengo, Otix, Pavone, Richter. Well, let's start from question number 2, which is the key question before I can answer the first and third question. We are in this product revolution. The value chain is being revolutionized. Data is like oil, not because it can be sold, but it can fuel this new mobility experience. Data, its collection, processing is the typical first step do while using cloud. And this is a big thing, especially when we really think of autonomous driving. A single test may generate 1 terabyte, many exabytes. But not only that, we need to make data available to the whole organization, and this is a first change in our organization. We insist on data. We have just published our position paper on automotive news, and we have case studies with the BMW. We have our live stream show on this question of data. When it is well organized, integrated, and distributed organization-wide, can we, of course, enable answers number 1 and 3, like the applications to open, unlock and lock the car remotely, or do maintenance. The second thing is to do machine learning, create artificial intelligence, so training, machine training and learning, and then execute simulations, test software on the vehicle. A second aspect has been perfectly referred to. It is a disruption, being free from a certain device. This is at the heart of this operation. We call it differently, but at the end is different. Software-defined vehicles. That's what we use as a concept. This concept has become a mantra, as customers also expect, and it can be implemented in 2 ways. First of all, bring cloud into the car, and that the logic is based on microservices, so you have to unbundle these services, make them more modular, and using standard interfaces, KPIs, to make the use possible. And this brings me to the third reply. It means applying the business models into the car that are present on the cloud, like geo-referencing, paying, making a reservation for one's parking lot, and so on and so forth. So you can extend these services to clouds. And this is even more important than the rest. So data is like crude oil. Why should we bring the cloud into the car? It means executing the software as though we were in the car. And this is automotive cloud make, facilitating scalable software. Scalability is one of the cloud characteristics and development. This and gives it agility, and this is key as the software develops. And only through software production, through artificial intelligence, and thanks to this scalability, can it be practical for companies. Software has to be continuously updated on a daily basis, and that has been the great advantage for Tesla, for example. But let's get to the heart of the matter. What are the user contents? What is the change that is brought about? Safety and security. We shouldn't think of autonomous driving vehicles being driven by themselves, but it is possible to design these types of vehicles thanks to artificial intelligence by increasing safety and security. That means saving lives and saving social costs. But let's talk about safety first. What we want is to give continuity to a digital experience rather than to bring about change. When you enter a car, we want the experience to work as a software infotainment. So we need to enable infotainment, high quality digital experience within the car, as assistants like Alexia in terms of artificial intelligence, connectivity on a constant basis. The car will turn into a smartphone on wheels. When it is just released by the factory, it is at the beginning of its pathway, and then it will develop, and it is difficult to say what happens. When iPhone was launched, nobody would have imagined Instagram or TikTok or other apps, and today the cloud has enabled many of these applications, and now the potential is there to enable a similar type of experience if we do the right things and if we enable companies to act accordingly.
Did I answer your question? Yes, you did, absolutely. Your speech was very interesting, by the way. And I repeat, we don't have much time. What we can do today is to give some deep divings, some food for thought, so that we can further develop this subject on other occasions. Marco Pavone is associate professor at Stanford University. As many of you remember, Stanford University is known or renowned for the car who won the Dark Challenge, if I remember correctly. And we would like to hear your point of view on the self-guiding cars, on the autonomous cars, which have been at the center of the debate on many occasions during the 4 or 5 years ago. Now is the time for silence, because the transition to the e-cars took over at investment level and at communication level. Now we restart the debate, and what I would like to see today actually is what's the state of the art today, and what are the future perspectives of the self-driving cars, even if the perspectives seem to be reduced compared to what the expectations were in the past. What we see today is that we came to a standstill, and we are at the point of 2.5 of the SAE scale. So how can we overcome this problem? First of all, thank you very much for inviting me. I start by saying that I fully agree with many of the things that Stefano mentioned. For example, transporting many aspects of the vehicle into the cloud. I have a scholar perspective and a technical perspective. I'm a professor at Stanford University, and I also managed the research unit in the field of self-guiding cars. So technology centering around self-driving cars, as the most part of new technologies, at the beginning has lived a period of expectations, probably too high expectations, as you mentioned. But after such exaggerated expectations, we had to leave a period of solutions, proposed solutions, in which we understood what is feasible and what's not. And then there is a period of evaluation, of assessment, whereby we actually understand what can be done at mid-term and at long-term, and we start planning the products. So in the case of self-guiding cars, we overcame the peak of exaggerated expectations, and we are now in the period where we have to reconsider what can be done and what cannot be done. This being said, the investments in this field are still very high. The ecosystem has been reorganized in the last 2-3 years, and mostly in the last year during the pandemic period. Many companies, many startups have been taken over by bigger companies, so we had to leave a consolidation period in this field, but investments are still very high. First of all, as you already mentioned, as Stefan already mentioned, one of the most immediate applications of the technologies correlated to the self-guiding cars, such as the perception, the control of the automatic vehicle, are being implemented in the context of assisted guided cars like Tesla. And this product is being promoted, and many manufacturers will be introducing this new system that allow us to automatize a vehicle within the next 3-4 years. As Stefano mentioned already, this is basically a very important factor showing how we can interact with the vehicle, and will probably bring us to avoid many accidents, so to a reduction of losses of human lives. This being said, the car completely without driver is already a reality in very limited contexts. Starting from October of last year, we tested a service of shared mobility based on self-guiding cars, and news is that such cars used by Waymo, which is the group dealing with autonomous cars, these cars do not have, as I said, a safety system inside the vehicle. So there is just a passenger, it's just a product. And at present, these cars are operating just in Phoenix area, but the service works quite well. There are a series of videos you can watch on YouTube showing how it works, and many customers posted videos on YouTube showing how it works. And the most interesting aspect is that the self-driving car does exactly what the people expect, and there is nothing particular about that, nothing special. And that's already per se a good news. There is a moment in which we reconsider this technology, even if it is already having an impact on self-guided cars, very advanced system. There are services being delivered when it comes to self-guiding cars in the context of a shared mobility, and this represents already a first application of such technology. This being said, this technology is not only important in the mobility context, but also in many other contexts as well. For example, the logistic context, which is probably more industrial. And this is a field of application on the technological point of view, which is very interesting, but on the business point of view, that's important too. So we speak about self-guiding cars in the mobility sector, and we are already doing many steps forwards. But actually, basically, this technology can be applied in other sectors, in other fields as well, and this is fundamental too. So, following the expectations, this technology is doing many steps forward. So I expect to see within the next 4-5 years an increase of this technology, especially in the advanced self-guiding systems for cars. You mentioned Tesla, and Marzani did the same before, but how much this update, to what extent this software is really advanced in terms of autonomous guide. It's true that Tesla is probably moving forward much more if we compared it with other companies. What great question. Given my position, I prefer not to draw a ranking of the various manufacturers. Well, Tesla has a very advanced concept and has been pioneering in various fields, as for example in the field of the software update on the vehicle, which is a trend on the rise in the automotive sector. So as I said, the advanced self-guiding systems for cars are systems that are in development in other companies as well, and also by Tesla, but not just Tesla. Tesla is pioneer in various trends, as I said, also for the periodical update of the software, also for bringing the data into the cloud. But within the next coming years, there will be a series of competitors as well investing in this technology. And we have to consider the Chinese manufacturers as well, which are not really well known by the press, but which are doing really huge steps forwards in the context of a self-assisted guide, self-assisted cars, and also in other fields. And this is a great news. The ecosystem is sound when there are many stakeholders acting on the market. Thank you. Now it's about time to delve into the local territory with three companies which are particularly active in the field of AI and digitalization. I would like to start with Andrea Bozzoli, which is CEO of HBOX, and I will ask him how his company applies AI in the most traditional fields of activity. Yes, good afternoon. Thank you for inviting me. First of all, as Marco Pavone said beforehand, we realized how the investments centered around AI are enormous. We speak about $3 trillion invested in AI applications within the next 5 years. We had the chance to speak with one of our biggest partners, which is investing 300 and more, 3 billion in hardware, in sensors. We spoke about Tesla, and it is a vehicle having an internal combustion engine and investing in sensors. So the sensors being at the base of AI, it is obvious how this approach, this technology has now become really an habilitating, improving factor that improves the life of consumers. So we asked ourselves how we could apply it, also considering the fact that we didn't notice a systematic approach and an availability of the demand in AI applications in the sectors where we operate. So we think that the added value that we can offer to our customers is in the field where we have the most experience in the product development process. So we got organized with our business unit, which is dedicated to this kind of activity, and we organized all skills of our engineers, organizing a series of tests and exercises. We have networks based on mathematical algorithms, and which are created and adapted according to the quantity of data they need to manage. So we organized our capacity of penetrating the market. We worked on two big subjects. The first one is to make the task easier for our customer, for the customer who operate the assembling systems and the training systems. So we didn't follow as it was the case. We didn't adopt a Big Bang approach with the creation of a platform. We opted for another possibility. We identified a series of cases that could help us to solve the problems that our customers have every day on the mountain lines in their commercial or a productive production activity, or in processes affecting actually the creation and the sale of products. If you want, I can also illustrate and mention some examples. We looked inside our development department in the components we produce to demonstrate that we believe in AI, because the customers tell us, yes, you're offering us this product, but inside your company, what are you doing? What's the process? What are the processes that you're managing? So the most interesting part is the development of our engines and of AI systems, of neuronal networks that already in the development phase are capable of gathering data. And this data basically help us to make the product more reliable, more reliable. If you want to realize a smaller engine, but you can make it more efficient. You can use data so as to make it more efficient and accurate. So this was done during the development phase, but also during the production phase, we used two small sensors and detectors, and on the basis of this work that has been done, we wanted to be more credible, and we wanted to benefit from a more important support. We wanted to get to cooperate with a series of companies. We wanted to act in a structured way so as to actually better organize the way of working, and to better invest in the detectors and other components, and to act to better develop the spare parts and to add them to our product. This help us to have a better proposal, to offer a better maintenance service, and to intervene before the engine breaks down. Rather than having informations on the sound of the engine itself, and we invested on engines, and we tried to understand how they worked to be able to intervene and to solve the problems correlated to that. We deemed it was more necessary than doing as we did in the past. So one of the limitations that the electrical engines have is the thermal reserve they have after you accelerate 2-3 times. It is not possible to keep on using the same performance of the engine. The fact of wanting to improve the efficiency of our engines allows us to improve the efficiency and the performance. We could increase up to 20% the possibility of using the electrical engine on the vehicle. So these are all applications on our point of view that are very important. We are a development company, and these applications help us to activate in a more precise way our capacity of development on our products. Thank you very much. Andrea Bozzoli, Francesco Ortix. He's the CEO of the R Group, and his company operates in the field of a human-machine interface, and he recently did some integrations on high-performance cars. For example, the integration of Alexa. Can you tell us more about the challenges that we will have to face in the future? good afternoon, and thank you for inviting me. I will try to present our experience and our challenges, technological challenges. Of course, the integration of services inside the cars is radically changing the conception of interfaces between man and cars. It is changing the experience at 360 degrees. The integration of Alexa is an eloquent example, and it's changing the conception of vehicle. In the past, we used to actually to use the USB key to listen to music. Now, this system simplifies the complexity of a car, giving at the same time a great benefit to the user, because the user can always have updated contents and can always improve the mobility systems. One of the examples is the great advantage of the online traffic that can help us to avoid traffic jams, or the selection of the car park that it can be useful in the very crowded areas and give us the possibility not to wait too long in line. This trend will imply a shift of services from the vehicle to the cloud system, and will bring with itself some complex aspects. Complexity has to do with some technical issues and some challenges. And the first complex aspect is the need to keep a strong integration between the cloud and the car. Too much information can have the risk to be too confusing. We need to interact with the car. The message is HMI should give information in a secure way, and it should become the main source of information during the driving, but not a source of distraction. Machine learning plays an important role in that field, and it evolves in time and changes according to the tastes, to the conditions of driving conditions in the traffic or in free roads. If I am in a very twisted area on the highway with a lot of traffic, well, HMI intends to reduce the information available and to give to the user the most important one. Another complex factor regards the possible infrastructural gaps that can compromise the user experience in the vehicle. This is true when we actually go outside of the cities or go far from the cities. If the connectivity is lacking, the user perceives, for example, disturbance. The map is not downloaded, the music doesn't play anymore. So this should be mitigated by reasonable usage of data, management of data inside of the system and inside of the cloud to be able to give a full experience. And the most important factor, as Stefano Marsani said, is how can we create value in the big amount of data being conveyed. It is very complicated to determine. A vehicle can download a very big amount of data, a great quantity, and can transfer a big amount of data. So the first part of the challenge is how to manage this great volume of data, how to choose the most significant, the most important ones. The second part of the challenge is to understand how to create value on the basis of such data, well, on the basis of the interaction of added value services, ranging from the end customer to the producer and to the suppliers. So we are currently concentrating on the services such as insurance services, predictive maintenance, fleet management services, which actually are the basic services. So we are speaking about transforming this data. The market is not yet proposing something structured, and mainly the automotive industry and the production chain is still looking for the new services to that can create added value when managing data. And I conclude recapping and saying that as a company, our main objective is to find and create value for the whole production chain, starting from the data and going to the cloud. Thank you.
Siamo quasi agli sgoccioli come tempo, però
We are almost finished, but I would like to hear Giovanni Fiengo's approach, which represents a very important sector in the field of AI. Fiengo, the floor is yours. Thank you.
Good evening, and thank you for your invitation. For me, it's a great pleasure to be here. Kineton was created recently, and we're growing. We develop software and in the automotive world, and for these two industries we are trying to convey our experience that we developed in the software world inside the car in order to conceive, to design a car as a part of the network. And we deposited the brand Internet of Car. I agree with what Stefano said, and we try and take the car in the cloud, and we develop the software. Could be for the infotainment application or safety or self-driving and driverless car. It allows her to collect data, a huge quantity of data that are analyzed and treated and transformed into values that are then treated by the artificial intelligence and machine learning. So in September 2020, we launched a spin-off of the University of Salerno, Kevlar, that is aimed at managing data, so data engineering, how this data can be transformed and developed in order to develop services. We call it Kineka, which is a digital cockpit, allowing us to develop the car software from this point of view. We will launch it to the IBC trade shows in Amsterdam in December, which is the most important trade show in the media world. We decided to present this project in a media trade show rather than in an automotive trade show, because we want to stress the importance of this media aspect. The car becomes a media content and not so much a vehicle. So everything that can be used inside the car, and we can, of course, boast important partners like Sports Italia and an Italian broadcast. And I cannot reveal the name due to privacy reasons, but we will present it in the. So thank you for your presentation. Our time is over. I had another question, actually. I don't know if we can use 2 minutes, 2 extra minutes. Please let us know, because this was the case. I would like to ask to our panelists what is the European space in developing artificial intelligence? Are then in between American, Asian giants, or can we maybe conquer our space? And what is the weight of individual talents and the role of individual talents in building up this European pathway? And in particular, young talent, if they have space in this field, and what should they do? Any answer? If I can, I would like to tell you a little anecdote, something that involves myself and Francesco. Maybe it is not known, but our team and Francesco's team at that time were the first to install CarPlay in a vehicle. It was 2014 on the Ferrari FF that was launched in Geneva. And I remember that with Andrea, Salvatore, etc. Why do I mention that? Because I think it's a good example. So the CarPlay technology was not invented here in the Motor Valley, was invented by Apple, and then it became a global technology. But we went there, and we were the first in the world to integrate it within the vehicle. And so that's the same thing for artificial intelligence, and it's very important. So to integrate the innovation, it is as important as creating new technologies, because products must be updated, because people require these products. So my suggestion is to explore, to go, and then to integrate back this aspect in the territory. There are important ecosystem, artificial intelligence. Marco was mentioning China, country that has a technological boom, so it's important to go there and then to learn and then to integrate, to create technology and to adapt it. And in this sense, the work that has been carried out by the Motor Valley, the ecosystem, the brand, is an exceptional work. So we need to invest in order to create, explore, and integrate. Indeed, some Chinese decided to come to your region to, set up a production, a manufacturing plant. So thank you for this interesting panel, and have a good day.